After discussing the molar heat of combustion, let's talk about enthalpy of displacement, also known as heat of displacement. This is the heat change that occurs when cations are displaced from their solutions. For example, when zinc metal or powder is added to blue copper 2 sulfate solution. So now, when we have addition of zinc powder to copper 2 sulfate solution, then we expect the following observations. Number one, a brown solid is deposited. And that brown solid is copper. Number two, the blue color of the solution fades. This is because the copper 2 ions responsible for the blue color have been displaced. Temperature rises. That is another observation. There is temperature rise. i.e., the initial temperature of the solution before addition of the metal is lower than the final temperature after the addition. And we have said the blue color of the solution fades because the copper 2 ions responsible for this color are reduced to copper metal. And it's this copper metal that shows that there is brown solid formation. Now, in this given reaction, zinc solid is oxidized to zinc ion. And the kind of equation I will have for that will be as follows. Zinc plus copper 2 sulfate solution will lead to formation of zinc sulfate plus copper solid. The reaction is possible in this manner just because zinc is more reactive than copper and can therefore displace copper from its ion. So this confirms that silver is not able to undergo such a reaction with copper 2 sulfate. Reason being that silver is lower in the reactivity series compared to copper. So if we visit the posokamal zinc, we realize that silver is very low in the series and cannot displace copper from its ion, meaning it cannot lead to formation of silver sulfate the same way as zinc has done. Ionic equation. So that is zinc solid plus copper 2 ions, that leads to formation of zinc ion plus copper solid. Visiting redox reaction, again we realize that copper is reduced. That is from +2 to 0 oxidation state, while zinc has been oxidized. That is from 0 to +2. That is a true confirmation that this reaction is fully a redox reaction, meaning oxidation and reduction take place simultaneously. Again, we have also realized that there is some kind of exchange of ion, and that is only possible because zinc is able to displace copper from its ion, and that is why the zinc as solid picks the sulfate ion and it leads to formation of zinc sulfate as the copper 2 ions are reduced to copper solid. The change in temperature shows that the reaction is exothermic. That temperature rise. The heat given out in the reaction is calculated using the formula, that is delta H is equals to mc delta T, where m is the mass, in which the mass is taken to be that of the solution and that of the metal added is assumed. Remember, mass of metal is assumed. So when you are talking about m, then fully it will be mass of the solution. Meaning, if you are using copper 2 sulfate as a solution, then there is full assumption of the mass of zinc powder that is added. Now, students, I want us to recall on how we calculate the delta H. We had said earlier that delta H is simply calculated by implying the same way we can calculate any heat change. That is mass times C. The C is the specific heat capacity that we had said can be either given in joules, that is 4.2 joules, or we can have 4.2 kilojoule. So it is the given heat capacity that will control the kind of calculation manner you want to take when doing such a question. Now, in an experiment involving the reaction between copper 2 sulfate and zinc powder, we will have the observations that we have just mentioned. So let us have a look at the kind of experiment that you're going to have. That is in that plastic beaker where displacement is taking place. As you can see, there is a thermometer. This is thermometer, and that is what will help us to note the temperature. Still, stirring is going on. The blue color is still visible, but after some time, after full displacement has taken place, there will be some brown deposit. When you're very keen, you'll see the brown deposit already has started to form, meaning after full time there will be a total colorless solution, that is zinc sulfate solution, but not now copper 2 sulfate, that is responsible for the blue color that you can see in the setup. Now, let's say that in this experiment there is use of the following: 100 cubic centimeters of 1 molar copper 2 sulfate, 0.15 grams of zinc powder. We can also have initial temperature that is well known, and in this our experiment we can take an initial temperature of let's talk of a temperature of just about, or if we have initial temperature of 25 degrees Celsius and final temperature of 49.5 degrees Celsius. So from there we'll have a temperature change of 49.5 minus 25.0 giving 24.5 degrees Celsius. Let's talk of mass of zinc, maybe to be a larger mass, a greater mass of about 4 grams. Good. We can use these to calculate the following questions, that data that we have. The first one is moles of zinc. We can calculate molar heat of displacement. Displacement of copper 2 ions. Yeah. Then we can have the writing of the thermochemical equation. And then representing the thermochemical equation in the energy level diagram. These 4 elements will help us understand more to do with molar heat of displacement. Solutions. Question 1. The calculation of moles of zinc used. Moles of zinc used will be mass over molar mass, and the molar mass of zinc is 65 grams per mole. So that is a mass of 4 that was used, divided by 65 grams per mole. That gives that is 0.062 moles. So that is the moles of zinc that is used. Let's calculate molar heat of displacement of copper 2 ions. We'll start that by obtaining delta H. So that is equals to MC delta T. M is the mass. That is simply 100 grams. Divide by 1000 to convert that to kilogram. Multiplied by 4.2 kilojoule per kilogram per Kelvin. The change in temperature is 24.5. Well, so that gives 0.1, that is 100 over 1000 will give 0.1 kilogram, multiplied by 4.2 kilojoule by 24.5. Remember, a change in temperature can be either in Kelvin or degrees Celsius, implying that even if you have to convert the two temperature values in Kelvin, then the difference between them will still be 24.5 as the change in temperature values. Well, if you divide that by kilogram by Kelvin, that and that vanishes, these and these also vanish, giving us 10.29 kilojoule. Let's go ahead and calculate molar heat of displacement of copper 2 ions. To do this, we have to start by calculating the moles of zinc ions that are used. So moles, the moles that produced that given heat. So that is a moles is equals to molarity by volume. The molarity here is 0.5 multiplied by the volume that was used, that is 100 over the 1000, because we are using the volume in liters. So that will give 0.05 moles. So it means that when 0.05 moles of copper 2 ions are displaced from solution by zinc, that is of 4 grams, then we shall have 10.29 kilojoule of heat evolved. Good. Let's go ahead and calculate now the molar heat of displacement. So that is, if 0.05 moles is able to generate 0.05 moles is able to give 10.29 kilojoule. What of 1 mole? So that gives 1 mole multiplied by 10.29 kilojoule all over 0.05 mole. So that gives, if we divide, that is 10.29 divided by 0.05 gives 205.8 kilojoule per mole. This, the molar heat of displacement, is exothermic. Heat is evolved. Heat is evolved. Therefore, the molar heat of displacement of copper by zinc is negative 205.8 kilojoule per mole. Thermochemical equation. Let us write the thermochemical equation. That is zinc solid plus copper 2 ions, that is in the solution, and that gives zinc ion plus copper solid, delta H is equals to negative 205.8 kilojoule per mole. That is the thermochemical equation. Finally, we can have the illustration in the energy level diagram. How to represent that in the energy level diagram. That is the y-axis, x-axis, the reaction we have said is exothermic, meaning there is a heat that is lost. So that is why we have the products zinc ion plus copper solid. There is activation energy. We have delta H is equals to negative 205.8 kilojoule per mole. This represents reaction path. And then here we have the enthalpy content in kilojoule. So that is the illustration in the energy level diagram for the displacement of copper from its ions by use of zinc powder. The molar heat of displacement, by definition now, is our next center of discussion. How do we come up with the molar heat of displacement? So this is simply, just like we said, the molar heat of combustion. This one also involves the displacement of a given mole of a substance. So like for this case, what we have just discussed, we have looked at the displacement of copper 2 ions from copper 2 sulfate solution by use of what we call zinc powder.